the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, Wiz. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self-paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Yeah, so hello everyone. Good evening to everyone present here. So can I please have a +1 in the chat, and can you kindly write your name in the chat box, those who are present? And just give me a confirmation that I am properly audible and visible. And my screen is also getting shared. Just a minute, let me share it. Hmm. So yeah, I see 6 people with me. Let us wait for a couple more minutes for the other people to join, and then we will very quickly start. Yeah, hello everyone. Can you please quickly write your name in the chat box? My screen is also getting shared. Just can anyone please confirm that everything is working in order? Hello Jyoti, how are you? Yeah, and just a confirmation that my screen is properly working. Hmm. Yes, thank you very much. Yeah, so I would request everyone to kindly do a +1 in the chat. Hello Yashvardhan, how are you? Yeah. So let me clear this frame. So this was our yesterday session, I suppose. Uh, yes, this was from our yesterday session. So let's take a new slide. Hmm. Hello, hello. Yes. Hello, Yashvardhan. So, Yashvardhan, are you preparing for your upcoming internships and placements, or for your interviews? Do you have any interview scheduled right now? So, till Yashvardhan reply, let us continue then. So, basically, let me give a small introduction about this series. So, this is a series of SDE interviews preparation, and we started this week itself on Monday, 2 days back. So, the first topic that we are considering right now is binary search, and we did 2 problems yesterday, and day before that also we did a problem. So, so let me give you a small recap. So, majority of the questions that you will find in binary search are dependent on topics like binary search and answer. So that is actually a very important topic to study. So let's see. Okay, you are here for practice, Yashvardhan. No worries, Yashvardhan. Yeah, I see quite a lot of people live with me right now. Can you please, I request you all to write your names in the chat box or just simply do a plus ones so that I can know you are an attendee to my session, and that will help me boost my confidence as well. Okay, yeah, so during our first session, we did a problem called aggressive cows, and in the second session, we did a problem called allocating minimum number of pages. So all these two types of problems are of the category binary search and answers. So as I said that if you are getting any questions in your online test or in your interviews, it will there is a high chance that it will be on this concept of binary search and answers. So there were other questions which I said you all to go through. The questions were finding the median of a two sorted array, finding kth element in a two sorted array, painter's partition problem. So these three are also very famous other types of binary search problems which are frequently asked in interviews. So this was about. So in today's session, we will also be exploring another problem on binary search itself, and let us see which one. So meanwhile, hello Anurag, how are you? Hello Vignesh, how are you? Okay, so let's start then. Yeah, and in yesterday's session, I actually gave a code forces question, which was also very similar to binary search and answer. Uh, is there anyone who was present in yesterday's session? Yeah, so this was a link of the question which I gave it yesterday, and you all can try this out. It's a really good question and actually very forward as well. So if your concepts on binary search and answer is clear, you will be able to crack this question. Okay, so let us see what we will study today. Yeah. So in today's session, I was thinking, let us. So I was thinking to do a little bit of easy and medium level questions so that we can cover around two or three questions in this session itself. So all will be involving binary search itself. Okay. So let's see and do that. So the first problem that we will do is called finding the peak of an element in an array. Okay. So let's see what is exactly the question. So I'm sharing the link with you in the chat box. Yeah. So and this is the link. So let us read the problem statement. So the problem statement is that an element is called a peak element if its value is not smaller than the value of its adjacent element. Now you are given an array of size n, and you are supposed to return the index of any one of its peak element. The generated output will always be 1 if the index that you return is correct. Otherwise, the output will be 0. So this is basically the how the answer is working in the backend. But you get the question right. The question is you're given an array array ARR of size n. You have to return the peak element of the array. Okay. Now you have to do this in with binary search. Okay, so how will you do this? So let us look into a few example of this question. And in case if anyone has any ideas, they can share it in the chat box. So this is actually a very easy question. I suppose many people would have just got us a very straightforward idea to solve this, but we will be solving this using binary search only and not any other method. Okay, so let's see that. Um, let's say that one of our examples are 3, 5, 4, 1 and 1. So in this question 5 can be one of the peaks, right? Because 3 is less than 5 and 4 is also less than 5. So 3 is here, 5 is here and 4 is here. So 5 can be one of the peaks, right? Now let's say we also have another element for if we take the another example 2, 6, 3, 7, 8 and 9. Okay, so let's say we have this element so in this case what will be the peak? Can anyone tell me? So the idea of the question is that there can be multiple peaks in the given array. So let us say that yeah. So if we're dealing with 6, we see that 2 and 3 are less than 6. So I can say that 6 is one of the peaks. Okay. Then again we see 9. The element 9 has 8 in its left side. So 8 is less than 9. So 9 can also be one of the peaks. So you can either return 6 or you can either return 9, or the question is asking you to return the index of the 9. So any straightforward idea that you can tell me that will help us solve this question? Hello Anurag. Hello Vignesh. Any ideas? Hello Yashvardhan. You can write in the chat box. Yeah, I'm waiting for anyone to reply. Yeah, hello Vignesh. Hello Yashvardhan and Anurag. Are you all there? So you have to. What if the question is asking us that uh, return the index of any one of its peak. So for the second example, the index would be the first index would be 1 of 6 and the last index would be 5. So the answer would be either 1 or 5. You can return any one of them and the code will give you the correct answer. Okay. But the idea is how to get these indexes from binary search. Okay. So we know one concept and we discussed is that in order to apply binary search, our search space should be monotonic in nature. Okay. So do you see that the search space is monotonic in nature? Or is this array sorted or anything? No, right. So how will you apply binary search? And remember that you have to do this in login approach. The required complexity of this question is to do it in log-n approach. And how will you do it? If you see the complexity, you have to do in log-n approach. Uh, anyone, any ideas? It's like pivot element question. Yes, it is a pivot element question. But tell me a very straightforward forward idea. Okay, let's say that you are finding the index of the largest element. Okay, so the index of the largest element is equal to 9. 9 is the largest element and its index is 5. So in that case, you can very simply return that value and you will get your answer. Okay, but that is not the point of this question. The point is how will you apply a binary search on this array? Okay, so this seems to be a very easy question, but its accuracy is around 38%. So it seems like there is a slight concept that usually people get wrong in this. Okay, so we will be trying to discuss this only because this type of question are usually the building blocks of the tougher problems. Okay, so there can be one brute force idea that we can try out. The brute force idea would be to check out every neighboring element. Okay, so let's say I compare the number 3, I do a linear traversal of my array. I compare for every element, I compare the neighboring elements, the right side and the left side. If the present element is greater than both the right side and the left side, we can say that we got a peak element, and we can very simply return its index. Okay, so this brute force approach, what will be the time complexity of this brute force approach? This brute force approach will take a time complexity of big O of n. This is a linear time complexity, and we want to improve upon this complexity. So that is the reason we are trying to take help of the concept of binary search to solve this problem. So all the students who have joined new, can you all please mention your names in the chat box, or you just very simply do a +1? That would be enough. Okay. So before I continue further, let me just inform you more about this series. So this series called Interview Preparation Practice Session for SDE Interviews are focused upon delivering to you all the frequently asked questions on the interviews. Okay, so we are starting with the topics binary search, and we will move topics by topics, and we'll also be doing random problems as well. Okay, so that will be very helpful. And if you have any questions, or if you is there anything that else or any content that you would like at Geeks for Geeks to deliver, you can write that in the chat box as well. So basically, we thought that having this type of series will be helpful for our audience. So that is the reason we are bringing. We also have a dynamic programming series which runs on every Thursday and Friday at 10 p.m. on this very channel itself. Apart from that, we also have mock DSA live every Saturday at 10 p.m. So, in case if you want to have your interview scheduled at any of the mentors at Geeks for Geeks, you can just fill up the form, and we will make sure that you get an interview with us. Okay, so this is about the other aspects of this channel. So for that, I would request you all to kindly like our session and subscribe to it as well. We can check the neighbor and then check if it's monotonic or not. Then we may find its peak element. Maybe I don't know. Okay, yeah. What concept which you just told is basically a brute force concept, and it will take a linear time complexity. But we want to improve upon that. So how will you do that? That will take a big O of n, right? So I'm telling you to do it in big O of log n. So I'm not asking you to iterate over this entire array. I just want you to do log n operations, and you will get that. Any other ideas? So can anyone tell me how we will apply binary search on this problem? Hello Nikas, no worries, you are late. Today we are doing a very easy problem on binary search. So we did the medium and hard level in the previous two sessions, so we are doing an easy problem. You will find the link of the session in this chat box very itself. So you can try to write your approach. How will you do that? We find the left and the right neighbor and apply binary search in that range. So it means that how many times you have the complexity of binary search is log n. So it basically means that you will try to apply binary search n times. That would again become n log n, and we don't want that. Okay. So first we have to identify that why binary search works in this question. So let us say that you are given any array. Okay. So can an array elements be without a peak? So basically, let us consider first we have to prove that an array element will always have a peak. So let us consider any three numbers a, b, c. Okay. So if let's say in any chance if a is equal to b is equal to c, we can say that b is the peak of the peak element. Okay, because they are equal. The idea of a peak element is that the left and the right are should be less than or equal to that element. So if b is greater than both a and c, we can very simply say that b is the peak. And in fact, if let's say a is less than b is less than c, in that case we can say c is the peak. And if a is greater than b, b is greater than c, in that case we can say a is the peak. So in all the possible conditions, we are getting one particular value as the peak. Okay. So what we can do? How can we utilize this concept to apply binary search? Nikach, we by picking any random element, we find left and right neighbor and apply binary search in that range by picking any random element. Okay, let's see that. So what we will do basically here, let's say, I see quite a lot of people live with me right now. Can you please do a +1 in the chat? That would be very certainly helpful. So let us say what we do basically, we keep a start variable. So so let us say we keep a start variable that is the low point of a binary search and we take it as 0. And then we keep the last index that is the end variable and we keep it as n minus 1. We now take a middle value. Middle value will be 0 plus n minus 1 divided by 2. That will be the middle value, that is the start plus n by 2. So what we do basically here, so we are applying binary search on the indexes. Okay. So if mid is equal to 0, what does this mean? If mid is equal to 0, it means that you are basically standing on the first element of our array. In that case, what you will do, you will check whether ARR of 0 is greater than equal to ARR of 1 or not, or you will check whether ARR of 0 so if ARR of 0 is greater than or equal to ARR of 1 or not. If it is equal, in that case you will return ARR of 0. Okay. If not, you will return ARR of 1. So if ARR of mid is less than equal to ARR of mid plus 1, we can increase low by mid plus 1. Okay. If ARR of mid is less than ARR of mid plus 1, in that case you are increasing low by mid plus 1. Okay, you can do that. And you can also do something like this. If ARR of mid is less than, let's say ARR of mid minus 1, in that case you can do end is equal to mid minus 1. Both will be correct. Okay, but the thing is that you have to check few things here. So let just a minute, let me. Yeah, so the basic idea of this question is lying in the idea of binary search. So we will be checking whether the middle element is the peak element or not. If the middle element is not the peak element, then check if the element on the right side is greater than the middle element. Then there is always a peak element on the right side. If the element on the left side is greater than the middle element, then there is always a peak on the left side. So we can do this either with the help of an iteration or with the help of recursion. So both would be working in this case. Okay. Let me write the function then. So this is a function which will implement binary search in recursive fashion. Okay, so what is happening here? In this case, I am passing the array. The low value will be 0, the high value will be n minus 1, and n is the size of the array. We are finding the middle element. Now, what we are checking, the first thing we are checking whether mid is equal to 0 or not, or whether mid is equal to 0, or error of mid minus 1 is less than equal to error of mid, or the case when mid is equal to n minus 1, or error of mid plus 1 is less than equal to error of mid. In both of these cases, what we are doing, we are comparing the middle element with its neighbors. Okay, so if that is the case, we just return mid. Else what we do, if mid is greater than 0 and error of mid minus 1 is greater than error of mid, in that case we try to find, we go to the left side of the array. That is, our end will become, high will become mid minus 1. Else we go to the right side of the array. Our low becomes mid plus 1. Okay, so if the middle element is not the peak and its left neighbor is greater than it, in that case, the left half must have the peak element. Same applies to the right half as well. If the middle element is not the peak and its right neighbor is greater than it, then the right half must have the peak element. So this is a very simple concept that we are using to solve this problem. Okay, so any doubts here? Yeah, Utkarsh, you are also correct. If error of mid is less than equal to error of mid plus 1, we can increase low by mid plus 1. Else we decrease high by mid minus 1. Yeah, Utkarsh, you're correct. Any more ideas? Okay, Utkarsh, we can calculate mid, compare the left and right if mid is equal to 0. Yes, Utkarsh. Hmm. Yeah, that is great. So now what we have to do? Now since we created a wrapper function, we have to call this function. Okay, so low will be 0, high will be n minus 1, and the length of the array is n. So we are passing these values, and whatever will be returned will be our answer. Okay, so let's compile this code and check for its whether it is correct or not. Okay, so no compilation issues, and let us submit this problem. Yeah, so as you can see, this problem is correct. If m is equal to 0 and n equal to 0 for I equal to 0 to n, if m is return, and if m is equal to error of I. Naikaj, I don't understand exactly what you're trying to say here. Yeah, so all the students who have joined a bit late, can you please do a +1 in the chat so that I can know your name and you can mark your presence as well? Okay, so this was about this question. So let us move to the next concept. So let us move to the next question. And before I move to the next question, let me just inform to the audiences who have joined late. So So what we will be basically doing, we are having a session called SDE Interviews practice session. This will be on every Monday, Tuesday, and Wednesday at 9 p.m. Okay, so you can regularly attend this session. So we will be going topic wise, and we will be selecting the most frequently asked interview questions, and try to deliver that to you all. Okay, and apart from that, we also have a DP series going on every Thursday and Friday, and we also have another live mock DSA on this very channel itself. So if you are preparing for your interviews, mock sessions are extremely helpful. So you can sign up for those interviews, and we will have this schedule on every Saturday at 10 p.m. Okay, so kindly check that out. And we also have a course called Complete Interview Preparation. So if you are preparing for your interviews, upcoming interviews, and you can definitely purchase that course. That is an extremely well crafted course which contains all the frequently asked questions. So you can definitely try that out. Hello, Battu Sarath, how are you? So let's move to the next concept that we want. So how many of you all know about upper bound and lower bound? Can anyone write a summary of the upper bound and lower bound function? So can anyone just in very brief tell me the concept of upper bound and lower bound and how binary search is implemented here? So what does lower bound does? Lower bound returns an iterator pointing to the first element in the range, which has a value not less than the given value. And upper bound returns an iterator pointing to the first element in the range, which has a value greater than val. So make sure that you know the concept of upper bound and lower bound, and then never get confused in this, because in majority of the questions which actually involves binary search, you can very easily get the upper bound and the lower bound by just this function and knowing what this function does. And what is the complexity of upper bound and lower bound? This is also important. So both, since both are taking the application of binary search and going over linearly, the complexity is n log n. Okay, for both upper bound and lower bound. So let us move to the next question that I was supposed to teach. Now this question is called searching for a number in a rotated array. Yeah, so I'm pasting the link of this question here. This is also an easy level question. So can anyone tell the idea of this question, how we will solve this? How you will search an element in a rotated array. So let's say you are given a sorted array and the array is rotated. Okay. So so it is rotated by some point and you are given an element. The task is to find the index of the given element key in the array. So this is a slight modification. So let's say you have a sorted array. So 1, 2, 3, 4, 5. Now what I do, I bring 4 and 5 in the beginning of the array. So now the array becomes 4, 5, 1, 2, and 3. So the array just got rotated. Okay, but it is still sorted in some fashion. So now you have to find I give you any particular number and you have to find the index. Okay, so how will you do that? So let's say the number is 4, 5, 1, 2, and 3. I'm asking you to find the index of the number 2. In the original sorted array, 1, 2, 3, 4, and 5, your index of this array would have been, for 2, the index would be 1. But in this case, the index is equal to 0, 1, 2, 3. Okay, so in the rotated array, the answer would be 3, and in the normal sorted array, the answer would be 1. Okay, so everyone knows how to apply binary search in a normal array. But now the question is, how will you apply binary search in a rotated array? Can anyone tell me the concept? Nikach, can you tell? Hello, Utkarsh, are you there? Hello, decoder. How will you apply the concept of binary search on a rotated sorted array? Okay, you will be given the array, and you will also be given another number x. You have to find the index of that particular number. Anyone? Any ideas how we will solve this? Okay, so Utkarsh is saying that we can use the left and the right pointers to check in which part of the element is located, either on the left on mid or right on mid. Yeah, exactly. We will be doing something similar only. So let me tell you. So the array is not sorted in the usual sense, but you know that this part of the array is sorted in descending order, and this part of the array is sorted in ascending order. Okay, the rotated array doesn't mean that the sorting of the array got destroyed. In fact, the array got divided into two parts, and both the parts are sorted in some particular fashion. So what we will do, we will keep our low equal to 0 and high equal to mid minus 1. Okay, we usually keep that. Now we calculate the value of mid. We will do that. After we calculate the value of mid, we will check if the nums in the middle is equal to target or not. Okay, so let me rub this. Okay, so we say low is equal to let us say that low is equal to 0 and high is equal to mid minus 1. This part is done. Now we will run a while loop. The condition will be same while low is less than equal to high. We will write a mid. Mid will be equal to low plus high divided by 2. Now after that what we will do, we will check if nums of mid is equal to the target or not. If it is equal to the target, what we will do, we'll just return mid. Okay, so return mid. Now, if it is not equal to target, we will check for first condition. The first condition is checking is that if nums of low, the value of low is less than equal to the nums of mid or not. Okay. So let's say the value of low is the first element of the array. It is less than or equal to the value of the middle element of array, is or not. So if this value is low, what does this mean? So let's say in our case when we were talking about let's say we had our array as 4, 5, 6, 7, 0, 1, 2, 3. Okay, so in this case, middle element would be uh, 0 plus 8 by 2. So middle element would be 4. So middle element would be 3. 0 plus 7 divided by 2. So the third index is 0, 1, 2, 3. Third index is 7. Now you are checking whether the value of 7 is greater than or less than the middle element. So see, if this part of the element is sorted in ascending order 4, 5, 6, 7, and this part of the element is sorted again in ascending order. So what does this mean? If 7 is greater than 4, it means that this part of the element is lying in particular. So the numbers from low to middle are in a sorted fashion. And if, let's say, I would have gotten element 1 as the middle. So if element 1 would have been the middle, in that case we can say that our we have to check to this side of the array. Okay, so this part of the array is a sorted fashion. So we are basically checking that in which area we want to be. Either we want to be this sorted array or we want to be this sorted array. So both the arrays are sorted. Okay. So now what we will do, if let's say if our nums of low is less than or equal to the nums of mid, it means that we are in a sorted fashion. Now we will check if nums of low is less than equal to target or not. If nums of low is less than equal to target or not. If nums of low is less than equal to target or nums of middle is greater than equal to target. Okay. Or nums of middle, this value is greater than equal to target. If both are true, it means that we have to move high is equal to mid minus 1. So we have to move to the left side of the array. Else we move to the right part of the array. And if when we come to the else part, we just do the opposite. Okay, so let me put up a code here, an implementation that would help you understand this. Okay, so this would be the concept here. If first we calculate the mid, we check whether it is equal to key or not. If it is equal, we return that. If not, we check whether a of low, the low part is less than equal to the middle value or not. If it is less than equal to middle value, it means that we are in a sorted array. Now we can apply binary search on this part. So if key value is greater than equal to the a of L and key value is less than equal to a of mid, it means that our answer will lie in this area only. So what we will do, we will call binary search for a, L and mid minus 1 and the key. If not, we will call for the next part. Same thing we will do if key is greater than equal to mid, a of mid, and key is less than equal to a of h. In that case, our answer is lying on this part. So we'll call the array for a, mid plus 1, h and the key. And finally, if both are not true, in that case, we'll call for a, L, mid minus 1 and the key. So this was the concept, and I suppose Utkarsh said this in the chat box. Yeah, thank you, Utkarsh, for mentioning the concept. Okay, so as you can see that all the test cases are passing, so therefore this question is correct. So do you have any doubts here? Hello, Naikaj, are you here? Hello, Utkarsh. Yes. So we are almost to the very end of our session, and yeah, And I would request everyone to kindly like this session and subscribe to our channel. So we are having this series on every Mondays and Tuesdays and Wednesdays. This will be a practice session for SDE interviews. Next week we will be discussing about bits manipulation. And apart from that, we are also having a DP series and a mock interview session on this very channel itself. Mock interview session will be on every Saturdays. And apart from that, we are also having a course called Complete Interview Preparation. The link of which is in the description. You can definitely check that out. Yeah, so you can definitely check that out. The link of the complete interview preparation. That is an extremely well crafted course if you are preparing for your interviews. Okay, so since anyone do not have any questions, so let us wrap up our today's session, and then we meet next week. Okay, yeah, bye bye.